bisector.
An angle bisector and perpendicular bisector. So again, make sure you understand the definition or the vocabulary for that. And then we introduce points of concurrency, which were where all of those met, and there's a special word for each one of those. So perpendicular bisector goes with what? Circumcenter. And angle bisectors go with incenter. Today we'll introduce two more. So if you're kind of counting this, this would have been 3 or 4 of our special segments, and this is all that would have. So number 3 is a median. So we've talked about median before. We actually just did this in 7th grade or pre-algebra. What's the median? In 7th or pre-algebra? The middle, right? The middle number. So what's the median in geometry? This is going to be a segment. Realistically, it could still be a line and everything, but usually this is definitely a segment that starts at a vertex and goes to the opposite. What'd you say? The middle, right? So it'd go to the opposite what? Midpoint. Of a side. Now, when we mean, or when we say opposite in this case, we really are saying what? Well, we're really saying diagonal. So, can you understand what that means? Can you draw that? So, what's the difference between a perpendicular bisector and a median? Does a median have to be a 90-degree angle? No. Does a perpendicular bisector have to come from a vertex? No. Right? So could a median sometimes be a perpendicular bisector? Maybe, right? But, so in order to do this one right here, if I'm going to draw my median, we call this ABC maybe. And we're going to call our median BD. The first thing that I want to do on AC is find the middle. So I want to find the midpoint. And then after I know the midpoint, I'm drawing it back to that opposite vertex. But that's really important that it starts actually at a vertex. Okay? That's really, really important. All right? And so then if we call this D, BD is a median. And again, because this is in the middle, this is congruent to that. So because of our median, AB is congruent to DC. That makes sense? So again, how many medians can I draw in a triangle? 3 again, right? So I would again find the middle of this side, I'd find the middle of this side, and I would just draw my lines across. Back to the vertice though, every time. That's the key to a median, that it hits the vertex. If it doesn't hit a vertex, you cannot consider it a median. And then hopefully if we did it right, we're going to have that point in the middle again. And so this is still my point of concurrency. And in this case, so another vocabulary word, this one's kind of easy for us to remember, I think, because median, somebody right away said the middle when we were doing central tendency. So this is called the centroid. So center, median, kind of go together. And this right here, the centroid, is always inside the triangle. So when you draw all of your medians, they should meet at a point always inside the triangle. So it leads us to our first theorem for today, which is 5-7. So again, it says that the medians of a triangle intersect at the centroid, which we just kind of explained right there. But then the centroid is 2/3 of a distance from each vertex and the opposite midpoint. So if we came back to ours, let's write that down. So if we come back to this though right here, and we're going to use this diagram again, we would come back and each of our others, we would put some letters. So let's put an E over here and an F over here. So basically what this theorem is saying then, we would say, notice that my centroid, let's call that K. So basically AE is one of my medians. It's going to be equal to, all right, this portion right here, AK, 2/3 of AE, the whole thing, is equal to AK. So essentially, this is worth 2/3, this is worth 1/3 of the whole thing. So if I'm thinking about the bigger portion, I'm going to say 2/3 of the whole thing. If I'm thinking about the smaller portion, which would be KE, then I'd say 1/3 of the whole thing. So every single time this is going to be true. This one would be 2/3, this one would be 1/3. This one would be 2/3. We're just doing it in the other portion of it, and then 1/3 and 2/3. So it happens to every single median, but they're not going to be congruent, right? The only way they're all going to be the same is if what? If I have an equilateral triangle. Make sense? Okay. Question 2. Last one. And then we'll get away from this. The last one is an altitude. Have you ever heard of an altitude? You would have probably heard of an altitude or altitude with respect to maybe an airplane or skydiving, right? Anybody ever skydive? I really want to. That story. So what's an altitude? What is your altitude? So it's your what? Your height, right? So altitude, in a sense, is a height, but again, this is a distance from an endpoint, or sorry, I don't want to say endpoint, I want to say vertex again. So notice what's important about the two that we introduced today. They both started where? They both start at a vertex. That's what's really important for the two that we are talking about today. Yesterday's, they didn't necessarily have to. Today's, they do. So the distance from a vertex to the opposite side that makes a 90-degree angle. So this one's a lot like what? Like a perpendicular bisector, but the perpendicular bisector didn't have to what? Start from a vertex. Okay? So, the thing I want you to do here is really overemphasize that this side is really long. So when I do this one right here, the only thing that I'm really, really worried about is that I find my 90-degree angle. Now again, it doesn't have to be perfect because I can tell everybody in the world that it's a 90-degree angle by what? Put in the box. Okay, so again, A, B, C, D, BD is an altitude. So the most important thing about an altitude is that it's 90 degrees and that it comes from a vertex. So here's the question, and this is where it gets a little complicated. If I want to do this from C, how do I do that? Say it one more time. Right, so this, I have to do it to this side over here, right? But can I draw a line from this C to over here somewhere and make a 90-degree angle? What I'm saying is this, right? Is that a 90-degree angle? Okay? So, big star here. Some altitudes. Will be drawn on the outside of the triangle. So how do I do that? When I'm going to figure out that here's my line and here's my 90-degree angle, I'm going to extend those sides. And then I'm going to draw my 90-degree angle. So an altitude can be on the outside. Especially for what kind of triangles would you say? Obtuse. And then think about an altitude for right triangles. Can I draw a right triangle? Right triangle, right? So what would I say about the altitude for a right triangle? It's really the what of my triangle? The sides or the legs, right? So for a right triangle, altitude is the legs or sides of the triangle. Or at least one set of them is, right? Because I gotta have a right angle. And so if I have a right angle, it's just like this. So this is an altitude because it made a 90-degree angle with one of my sides. And it started at a vertex, right? So my legs act as an altitude. So then the only other one that we would have to draw is this one right here, right? In our right angle. So I would figure out where I can get 90 degrees. I draw it straight back, and we'd put another box right there. We'll do a lot of geometry here next chapter maybe, with triangles like this. We'll talk about similar triangles then. Okay. So again, how many do I have in a triangle? We still have 3, right? Every triangle has 3. What are altitudes? That meet where? Well, we gotta have another word, right? So last weird word. This is the orthocenter. So our last point of concurrency is called the orthocenter. I think you actually have to draw this one on the test for sure, I think. But an orthocenter is pretty easy because all I have to really do is figure out where my 90 degrees is, right? And as long as I figure out my 90 degrees, my orthocenter in this one is actually right there. Right? Because here's my 90 degrees, here's my 90 degrees, and there's my other 90 degrees. Okay? This one right here, it would just be, I'd have to extend a little farther to figure out where they all connect. Okay? So the orthocenter is where they all come together. But there's no rule for the orthocenter, like what we had in the other books. Make sense? So, perpendicular bisector, it has to bisect the side, but make a right angle. It doesn't have to come from the vertex. That line can just come straight down the middle of your triangle. All 3 of them meet at the circumcenter, like Kenzie said earlier. The second one was an angle bisector. It cuts that angle in half, and we don't really care where it goes. They all meet at the in-center. And then the in-center was, because we were talking about angles, the distance back to each side was the same. Today we introduce a median. Medians have to start at the vertex and go to each midpoint or opposite midpoint. They connect or meet at the centroid, which is a distance of 2/3 of the whole thing. And then the last one was an altitude. An altitude has to start at the vertex, and then you make a 90-degree angle to the opposite side. But sometimes they're going to be on the outside, especially if it's an obtuse triangle like Mary said. All right? Questions here? Let's look at some examples. So, in triangle XYZ, P is the centroid and YB is 12. Can I find what YP and PV are? So, again, the most important thing is to just zero in on what they're talking about. They say YV, here's my YV. So again, the first part has to be the bigger number. If you forget what it is, how to do the math, it's always 2/3, 1/3, so it's going to make 1. And then the bigger side is always going to be the 2/3 part, right? So in this case, they ask you to find both of them. So basically, I find one and I subtract it from 12 and I get the other. So what's 2/3 of 12? 6? No. Half would be 8. So if this is 8, if YP is 8, what's PV? 4, right? Everybody okay? So again, you got to just know which one you're asked to find. So sometimes you might actually use 1/3. Sometimes you use 2/3. Sometimes you'll just subtract. I think pretty much basically the same thing. LO is 30. LO. Okay. So then what's LR? What's 2/3 of 30? 20. So 20 and 10. Makes sense? In triangle ABC, CG equals 4, we want to find GE. Well, why do they do all those little markings? They do all those little markings because they're trying to show you that they're all medians. Right? Because again, if it's a median, does it start at a vertex and then go to the opposite side where it goes right into the middle or the midpoint? Yeah, if you look at this one, for instance, right here, it starts at my vertex, it goes to the opposite side's midpoint, and so they are congruent. So then I focus in on what they're asking me, GE. So I'm looking at this one right here. If they tell me CG is 4, what is GE? Why? 4 is 2/3 of 6. Exactly right. So, my fault. CG is 2/3 of CE. Or as Dave said, 2/3 of 6. So we get our 4. If this is 4, then we go back and was that the answer, or did you have to subtract? I think you had to subtract, so it would have been 2. Make sense? Oh. Actually, let's try this one. I think I make you do one of these. An artist is designing a sculpture that balances a triangle on top of a pole. In the artist's design on the coordinate plane, the vertices are located at. What are the coordinates of the point where the artist should place the pole under the triangle so that it will balance? So basically, we're looking for the midpoint, right? So if we look at this one, oops, sorry. If we look at this one right here, we're going to graph it. And this is how they graphed it. Okay? So then basically what they're asking you to do is find the midpoint of it. And again, so in this case, we'd have to use our midpoint formula. Remember, the midpoint is always the average of the x's and the average of the y's. So we would want to put our pole right there so it could balance evenly. So you're just using the knowledge of what we've been talking about. But that's kind of a good one to go back and think about from past experience. And then, like I said, we show the ortho center, and again, this one shows all of them. But notice how we come back and we get our 90-degree angles, and then we would meet at the ortho center. So again, if you notice, this triangle right here was an acute triangle because all of the angles are acute. Notice that my ortho center could still be in the middle, but it could also be on the outside. So here they say the vertices of this find the coordinates of the ortho center. So this is where you would have to take the time to figure out how I could get a 90-degree angle. So what's the easiest way for me to figure out how to draw a 90-degree angle with or from this vertex? Well, obviously I'm going back to this one right here, right? But if I knew what this side slope was, what's true about the slope of something that's perpendicular to this side? It's the opposite reciprocal. So if I knew this slope and I knew the opposite reciprocal, I could just go through and I could count it off, and then I would make my straight line. If you don't want to do that, you could get a protractor, and from this spot right here, you could pick a dot or put your center of your protractor on there, and then put 90 degrees along this way and connect the dots if you had a protractor. So if you didn't want to actually do the math, then you could get a protractor. But what you have to do is you have to go through the process of finding all of them. So realistically, I'm not going to do this whole thing. I'm just going to think about the slopes. And once I find that slope, then I'm going to use it from my vertex and then apply that slope, and I should get the same thing that they did right there. So they're going through the process of actually finding the entire equation. But realistically, to me, I don't really have to go through all of that because I understand that if I start at the vertex, I can do my opposite reciprocal slope, and I can still get the same thing that they're getting. So they're doing a lot of work here. We're trying to simplify it, especially in something like this right here, right? If I have to graph y equals negative 6x minus 21, that's going to be a pain in the butt, right? Because negative 21, I'd have to go down, and then my graph gets distorted because you're writing things or you're trying to make the, what do I want to say? You're trying to condense your graph a little bit and so on and so forth. But what they're saying then is then you have to try to figure out where all of those meet. So once you get them all drawn, then you have to just take the two any two of the three and do some kind of systems of equations. So do substitution or elimination and figure out where that actual point of intersection is. All right. They didn't actually show you that, but we can go through that if you want. So here's a really good thing, and I believe this is in your book. So this actually shows you all of the 4 special segments that we have and what differentiates them. So this is a really good description of a perpendicular bisector compared to a median. See how they're both congruent, but one has to start from a vertex and one doesn't. One can be right in the middle. So the biggest thing is you got to remember which ones start from vertices and which ones don't have to. Basically, some of them can be a combination of both if you have special triangles like an equilateral triangle or maybe even possibly isosceles triangles. Then they could run into 2. And then they also show you those points of concurrency for each one and what their relationship is. So this is a really good chart, and I believe, like I said, I think it's in your book. So whatever page we're going to do our assignment, just turn back one page, and it should be on that page in your book. Otherwise, it can look right here. Looks like it's on page 339 if you ever need that. So if you want to put that in your notes, that this little chart is there. All right? So, questions with what we talked about today? Oops, I wanted that. So obviously, we don't have Jace today, so if you need to come in after school, I will be around. I know most of you don't like to do that, but it might be the only time you get time to ask questions. Looks like 31 is a proof again. It says write a paragraph proof, but obviously you do not ever have to do that again if you don't want to. So you can write your 2-column proof.